Okay, I'm going to scoot this down because there's one right below this. So these notes have to do with inequalities, so the greater than, less than symbols. Okay, and I'll go back through what I'm talking about with these things. Okay. While people are still writing, when do you hand in your notes? With the lesson quiz. Okay, so today you'll get the rest of the assignment to try on your own. It won't be due until Monday. Like I talked about, you'll finish it tomorrow after you do your test if you need to. Otherwise, it'll be homework over the weekend. But we'll grade it on Monday, and you'll have a lesson quiz on Monday. So on Monday, the only thing you're going to hand in with a lesson quiz are these notes, not the notes that you're trying on your own. Okay, so that we've got that, because these should be easy points and help out that lesson quiz grade if you don't get it the first time. Okay, so make sure you're copying these. Okay, so an example of the coordinate plane. So which one's your x, which one's your y, positive and negative directions. This is called point intercept equation. So y equals mx plus b. And I'm going to go through on how we break this apart. But the first part, and that's why it has a number 1 there, is we graph whatever is in this spot is where it crosses the y-axis when we graph it. And then whatever is in front of the x is your slope, and that's the second part. That's why there's a 2 there. You graph, and slope is represented as rise over run. So if you forgot which is which, rise is your y direction, and run is your x direction. Okay, now I'm going to scoot this down so you can see that last part. Okay, and then this says if the last step in solving inequalities, so the greater than, less than, is multiplying or dividing by a negative, that's the only thing that's different when we're solving equations, when we've got the inequalities, is that when you multiply or divide, the very, very last step in solving the equation, if you multiply or divide by a negative, then you've got to switch the inequality going the opposite way. Otherwise, solving equations is the same as it would be with equal sign. so I'm going to go back over this. You can choose to write this next stuff, or you don't have to. We won't check this part, but if you feel like it's going to help you remember for when you do the last equation, okay? So the greater than or less than, when there's no like equals below it, okay, is a dashed line. So what we're talking about, because we're going to solve equations and then you're going to graph them, okay? So when we graph them, so if this was my graph and I was to graph a line, if it has this, when we go to graph a line, instead of it being a solid line, it's going to be a dashed line, okay? So if there's no equals, it's dashed when we go to graph it. You graph it like normal, just not a solid line. If it has the equals, then it's going to be a solid line, okay? Because when we're graphing this, we're saying it's anything above or below that line, but it doesn't include anything on that line, okay? When it's equals, it means it's above or below and numbers that are on the line. So that's the difference between those two, okay? So paying attention on that. We won't have any equals here, I just put that there. So anytime we have x is like greater than some number or less than some number, or even if it's the greater than equal to, okay? It's going to be a vertical line. So it won't be slanted like this. It's going to be going straight up and down, okay, wherever it crosses the x-axis, okay? Because some of them will have y's in the equations, others will just have x's, okay? Now, the shading part. So it says the smaller part of the sign is facing the variable, and you're going to shade below. So what it's talking about is if you had the y equals mx plus b, and the smaller part of the sign, so the less than part, is facing the y, then you're going to shade below, okay? So if this was my line, and the smaller part was facing the y, I would shade below. So that means I would put shading this direction, okay? Another way to think about it is on the y line, right? As you go up this direction, the numbers get bigger, right? And as you go this direction, the numbers get smaller. So they're saying whatever you're plugging in here has to be smaller, okay, which would be going down. That making sense? Okay, when we go to shape. Okay, and then the bottom one that I'm not going to scroll up just because I want to use that graph is opposite. So when the bigger part of the sign is facing the y, so if you have this, okay, the bigger part, then that means we would shade up above. Okay, so this is my line, the bigger part of the y is going to be going up above. Okay, so that would be that. Now, the left and right thing. This has to do with when it's a vertical line, okay? So if it was just an x is less than, okay? So think of your x line. As you go this direction, the numbers get smaller, right? Because that's the negative direction. And then as you go to the right, the numbers get bigger. So if I had a line that was this vertical line, because it's just an x, it doesn't have a y in it, okay? I would shade because the smaller part faces it. So that would mean that I would shade going this direction. Okay, so if it split and the x is greater than, and it's the vertical line, then I would be shading on that side. Okay, so that's what this part is about. This one and the one below is the shading part. So you're going to solve equations, we're going to graph equations, and then you need to know is it a solid line or a dashed line, and then which direction you shade it. Okay, and that's what this whole section is about. Hopefully you've seen this before too. Okay, so we've got that. I'll come back to this when we actually go to graph it. Okay, so here's our first problem. So in your notes, just rough sketch a small graph. Okay, we're just kind of estimating where it would be at. When you do the problems, I will give you graphing. But for these are just notes. Okay, so for this one, when we have x's and y's, our goal is to get it so that y is by itself and it's in this format. Okay? Other than it's not equals, it's going to be the inequality symbol. Okay, we want to get the y by itself, and the y is not by itself. What is in front of that y? -1. Okay, so really there's a -1. So this is a -1 times y, so opposite of that would be divide. And when we divide, on this side, you have to divide everything on the other side by that. Okay, on the previous page, that very last thing that you wrote, it says if the last step, and the only step that we had for this one, was to multiply or divide by a negative, then we've got to switch the inequality going the opposite direction. Okay, so this is where it applies. Okay, so Over here, okay, I need to switch my inequality. I'm only going to write it for that. Okay, so now it's y, right? Because negative over negative is a positive, it's gone. But I'm switching this inequality going the opposite direction. Okay, this is 1 divided by -1. You can leave it like that, or you can make it a negative x, right? Because it's still a -1. Okay, but what does this become? +2, okay? Because it's a negative divided by negative, so you get +2. Okay, we good to there? Okay, so the previous page, this is what I was talking about, the order that we graph these. Okay, the first thing, and that's why I had a 1 on the previous page, the first thing we're going to do is graph that. And that is where it crosses the y-axis, okay? So the y-axis is this one, okay? So I'm going to put a dot on the y-axis at a +2, okay? So I'm just, and again, you're just sketching, you don't have to, you'll just pretend 1, 2, put a dot. That's the first thing we graph. Good? Okay. Then from there, this is the second thing we graph. It's what's in front of the x, and we represent it as rise over run. Okay? So we can have it as a -1 over 1 or 1 over -1. Both of those are equivalent, just as long as there is only one negative. Okay? So from the dot that we just made, I'm going to look at this one first. Okay? So from that dot, my rise is up or down? No. This one. Up, because it's a +1. Okay, now my run is going to be left or right? Left, because it's negative. Okay, so it would be, so up 1, sorry, forward up, sorry. Okay, if I use this one, and I started at 2, I would have gone up or down? Down 1, and then left or right? To the right. Okay, so when you go to do these on the notes, you don't have to give me 3 dots, okay? I'm just showing you that if you chose, depending on which one you chose, you're still going to get the same line if we were to graph it, right? Because if I'm to draw a line through those, they're all going to be lined up, okay? So remember, if you take a flashback to the beginning of the year, we only need 2 dots to make a line, right? To connect the line, so you don't have to do 3, just do 2. Okay, now, solid or dashed? Solid. Okay, so we're going to solid. Okay, now the shading comes in. So the part that faces the y, okay, the part that faces the y is the smaller part. So am I shading above or below? When it's smaller. Below. So the y's get smaller going this way, right? So this is my line. It's not above. It's going to be below. So this would be my shading. You can just, when I did it, I just took my pencil, and turned it sideways and shaded it. So you don't have to go through as much ink. Okay, we good? Okay, let's try our next one. Okay, so we want to solve to get y by itself. So it looks like. Okay, so to get y by itself, I need to move that 5x over to the other side because it's supposed to be on the right side of the inequality. So when I do that and move it over to the other side, it's going to change from a positive to a negative. Okay, so I'm just writing what's left. I'm writing it in the spot that it's supposed to be in. And that just means that we shift that -35 over. Okay, so we're starting to get it into that format. Okay, now we're at where we were at on the previous one. So my last step is to divide by a -7. And when I do that, I'm going to switch this inequality. Okay, so when I divide by a -7, I have to divide everything by a -7, just like we did on the last one with the -1. Okay, so that goes away. But now if I switch my inequality, I divided by a negative, you can leave this or you can change it. Okay, you can leave it as a negative negative, or that would be the same as having a positive, right? Okay, because remember we only need to either go down to the left or up to the right. It still would be the same line when you connect. Okay, but this would switch to a positive left. Okay, so graphing. Remember we graphed this part first. So on the y-axis, I'm going to go up 5 and put it on. 1, 2, 3, 4, 5. It's positive 5. Okay, I'm going to, just because I just need to do one of them, I'm going to do this one. Okay, so from this dot, I'm going to go up how many? 5. Remember, this is your rise, and this is your run. So rise up 1, 2, 3, 4, 5. Okay, and left or right? 7. 1, 2, 3, 4, 5, 6, 7. Okay, so I'm connecting this dot and this dot. Is it going to be a solid line or a dash line? Dash. Dash. Okay, don't do this, I just want you to watch this. If we left it like this, okay, and I was at my positive 5, I just would have gone down 5 and to the left 7. It's still going to be the same thing. So you're just choosing one or the other. Okay. All right, now the shading part. So the part that faces the y, am I going to go above or below? Above, because the bigger part of the sign is facing the y. So my y's get bigger going this way. So the shade. You good? Okay, a couple more. We're really just repeating the same thing. It's just some of these equations look a little bit different, so I want to make sure I do a sample of each. Okay, so this one we need to get the y by itself. And when we solve equations, it really doesn't matter which side the variable is on as long as you get the variable by itself. Okay, so I'm going to leave the y on the right-hand side. Okay, but what do I need to do to get it by itself? Divide by 5. Okay, do I switch to inequality? Yes. No, because you're not dividing by a negative. This is a negative, but we're not dividing by a negative, so we don't switch it. Okay, so what I do to that side, I've got to do to the other side. Okay, so really, I have my y, my inequality, I have my slope. What part is missing from that equation? The b, right? There is no b, okay? So when there is no b, the number that represents there is nothing would be what? 0, okay? So really, this just means plus 0, like the b's not there, okay? So on your graph, 0 is at the origin, so that's where you start at. That's your first stop. Okay, from there, I'm going to go up or down. Down 3. So 1, 2, 3, and then which direction? Right. To the right. 1, 2, 3, 4, 5. Okay, solid line or dash line? Solid. Okay, now my y is on the other side, but I'm still looking at the part that faces the y. So is it going to be below or above? Below, because the smaller part is facing the y, so going down this way. Okay, now I could have, from the origin, switched my negative down here, just as long as there is only one negative, okay? So I could have gone up 3 and then to the left 5, and it would still be the same. Good? Okay, a little bit different one. This time there's no y. so when there's no y, then you're only solving for the x. And this is the one where I said when x is equal to some number, it's just going to be a vertical line. It's not going to be slanted. Okay. So we're just going to solve for x. So we only have one step on this, and it's to add by 7, right? Whenever I do one side, I've got to do the other side. But I don't switch the signs because I'm not multiplying or dividing. Okay, it's going to stay the same. Okay, so it does not cross the y-axis because there's no y equals. Okay, so it's just a vertical line at a positive 1. So on the x line at a positive 1, you just put a dot, and it's straight up and down. It's vertical. There's no slant to it. Oh, and it's a solid line. Sorry, I answered my question. So solid line because we have the equals. Okay, now am I going to shade to the left or to the right? Right. To the right, because the part that faces the x is the bigger part of the sign. So we will shade to the right. Because whatever I plug in here has to be bigger than 1. So that would be going to the right. Okay, we're going to try another one that doesn't have a y, but this one's just got a few more steps into solving the equation before you can do it. Okay, so 33. Okay, so to solve for the x, isolate the x. Before we can start moving things to the left and to the right, I need to distribute this. Okay, so this I'm not touching yet. 2 times x would be 2x. 2 times negative 2 would be a negative 4. Okay, now I can start moving things. Okay, I prefer to move the smaller x just because then you can generally avoid having negatives. Okay, so I'm going to move this x to the other side. So what I do to get rid of it on that side, I've got to do here. Okay, get the x by itself, so add 1, add 1. What's my last step? Do I switch the sign? No. Because the 2 is not negative. It's the one I'm moving, not the one that's over there. Okay, so I have to, it's a vertical line again, but I need to know kind of where that's at, okay, because that's not the rise and the run, okay. So a negative 3 over 2, if I were to change that to a whole number, approximate whole number, that would be what? Right. Okay, so we're going to the negative direction over 1.5, which again, I know you don't have lines on your paper, just rough sketch it. Solid or dashed line? Dashed. Shading to the left or the right? Good? Fairly easy? Okay, last one I'm doing with you, and then you're going to try one. Okay, fraction. Okay, anytime we have, and I just want you to get in habit of doing this. There's other ways to do this, but I want you to get in habit because sometimes you're going to have multiple fractions in solving an equation. I want you to know how to get rid of fractions. We don't like to work with fractions. I mean, I know you don't. I don't either. Okay, so something that you might have been taught if you had IMAC was that you multiply the whole equation by the common denominator. Well, the only denominator that we have there is what? 7. Okay, so we put parentheses around the whole thing because we got to rewrite the whole equation, not just part of it. Okay, and we put a 7 on the outside. And the reason why we're doing this is sometimes you will have like a 2 and a 3 and a 4, and you have to multiply the whole thing by whatever the common denominator of those numbers are. Okay. All right. So when I distribute this, this actually cross cancels with this. Okay, and that would just leave this. Okay, but this one didn't have a fraction to cross cancel with it, so that means you need to multiply that bisect. So that would be a negative. So this equation is equal to that equation. Okay, it's the same thing. Okay, now we can solve for x. So subtract my 6, subtract my 6. So 6x is greater than a negative 38. And then divide by 6. Do I switch my inequality? Nope, because a 6 is not negative. Okay, so x is greater than a negative 8. Okay, so I'm going over 1, 2, 3, 4, 5, 6, 7, 8. Putting my dot, it's going to be a vertical line. Is it going to be dashed or solid? Dashed. Shading to the left or the right? Right. Okay, here's your triangle. This is number 49. Got it. Okay, we good?